Okay, thank you. 458, I think they were saying, or they were asking how many words you can make if the letters can be repeated. So there were 8 options for all of them. For all 8 slots, right? There would be 8 options if there were 8 letters. Then for 5B, they were asking how many words you can make using those letters if the letters cannot be repeated. So that would then be 8, and then for the next one 7, and then 6 and 5 and so on. Then for C and D, guys, they were now asking how many 6-letter words you can make using those letters, right? So now if you wanted to do your lines, you would have to make 6 lines. So 1, 2, 3, 4, 5, 6. And then for the first one, for C, they said the letters can be repeated. So now you would do an 8 in all of them. Right? Does that make sense? Why it's 8 to the power of 6? Because there are only 6 slots now that they've given you. And then for the next one, they were now saying the letters cannot be repeated. So now it is, unfortunately, you can't do 8 factorial. Morning, guys. Just come get these pages quickly. Okay. Thank you. Thank you. Guys, if it's wrong to write that out, so if you wanted to write this in using like factorial notation, you could say 8 factorial divided by, now let's just quickly think, what is 8 factorial? It's 8 times all the way to 1, right? So times 2 times 1. So if you have 8 factorial, you can just divide that by 2. Right? Because this will be right? You know what I'm saying? I just basically canceling off the ones that are not there. 2 factorial. No. And then if the early ones is like 5 things, and not the 3, then which 5 by 3. But guys, if this one uses you, there's nothing wrong with writing it like that. I mean, at least it's the same concept. Okay, are there any questions on number 5? Number 6, this was the one that was quite tricky, 6C and D. I think 6A and B were not that bad. They said that you could, and now also guys, the thing is they said you could choose numbers from 0 to 8, which is a bit unusual. It's normally 0 to 9, right? So that's just something you need to pay attention to. So there are actually only 9 digits to choose from in this one. For 6A, they asked how many poets can you make if the left or the digits, can be repeated. So that would be 1, 2, 3, 4. There would be 9 options for all 4 of them. Right? That's like 9 to the power 4. For the next one, if you can't repeat them, it's 9, 8, 7, 6. Let's just quickly think, how could we write this differently if we wanted to use factorial notation? If we wanted to say 9 factorial, what is left? That would be a part of 9 factorial. That's not here. Yes, next. 5 factorial. But guys, it almost like takes the same amount of time to write those 2 methods. So yeah, it's up to you. They just use this in the textbook sometimes. I don't want you to see this and you don't know where it's coming from. Okay, the last one, C and D. Now I'm trying to remember. It says the digits can be repeated, right? And the number, the actual code that you're getting has to be greater than or equal to the number 4,000, right? So that means that, guys, it has to start with a 4 or a 5 or a 6 or a 7 or an 8, right? Does that make sense? If it's greater than or equal to 4,000, like the actual word of the actual number, I mean. Right? So it can be 4,000, it can be 4,001, it can be 4,100, it can be 5,010 or whatever. Okay, any number that's greater than or equal to this. So we have to have a 4 or 5 or 6 or 7 or 8. So that's why the first number there is 5. There are 5 options, right? Then after that, they also said it has to be divisible by 2, right? Okay, so the next two numbers could be 9 digits, it could be any one of those, it doesn't matter what those numbers are. But for a number to be divisible by 2, it has to be an even number, right? So it would have to be 0, 2, 4, 6, or 8. So that's why there are again 5 options for the last number. Okay, so then you would just multiply all of those together, 5 squared times 9 squared, and you would get your answer. And then for D, sorry about this, I just remember that there was some confusion about whether the digits may be repeated or not. It was actually a follow-on question from C. So the digits were allowed to be repeated, but now the only difference between C and D is in C they said it can be equal to 4,000. In D they now said it has to be greater than 4,000, right? So that actually just excludes that one number. So it can be, it can be all of the answers that you have here, except for the number 4,000. Okay, so here they say how many numbers greater than or equal to 4,000. Here, how many numbers just greater than 4,000, right? So it's just excluding that one number there. So you have to take that answer and just minus. Okay, then the rest was just grouping questions. So we can just take a look there. Exercise 5, number 3. So it was 5 boys and 4 girls. So for 3A, they just asked you in how many ways can they sit next to each other in a row. So that's just 9 factorial because there were 9 people. Now I can't remember all the other groupings. The next one was, I think there was a couple that wanted to sit together, right? So that means that the couple formed one group, and then all the other 7 people, they each form their own group as well. So there were 8 groups effectively, right? And within that couple, because there are 2 people, they could sit in 2 factorial different ways. Okay, so 8 factorial times 2 factorial, or just 2, that's also fine, guys. You can just listen to there. So that's the answer. Okay, so C, this was now saying all the boys want to sit together and all the girls. Okay, so do we agree that there are 2 groups? The group of boys and the group of girls, so that's 2 factorial. These are the 5 boys, how they can be arranged within their one group, and then the 4 girls within their group. Okay, then the next one, now I just need to try to remember. For D, they were saying the girls now want to sit together. Okay, so these 4 girls form one group, and then the 5 boys each form a group. So it's 5 boys plus one group of girls, so there's 6 groups. And then within the group of girls, 4 factorial, right? The next one was for the boys now want to sit together. So that is one group, and then the 4 girls each form their own group. So it's 1 plus 4 groups, so 5 groups. And then within the group of boys, they can sit in 5 factorial. Okay, so all of those are just grouping questions, but then for F, they said now the boys and the girls have to alternate. Now, guys, the other day we marked a question that was similar to this, but there were 5 boys and 5 girls, right? Now, because there are 5 boys and 4 girls, the only way for them to sit so that the boys and girls are alternating is if a boy sits in the first seat, right? Because there are 5 boys. You can't put a girl here because then you're going to have 2 boys sitting next to each other. Okay? So you would have to go boy, girl, and so on. So then I just filled in if the first seat has to be a boy, there are 4 options for that seat. All right, then for the next boy seat, there will be 4, and then 3, and then 2, and then 1. Okay, so the first girl seat, there are 4 girls, so there are 4 options, and then 3, and then 2, and then 1. So if you just look at the actual numbers there, that's actually 5 factorial times 2. How are we feeling about this question? This question kind of covered all the group types of questions that they can ask, except for obviously the one where it was 5 boys and 5 girls, but we have marked that one. So you have multiple options. Okay, then I move on to the next one, which was number 4. Okay, so these were just the textbook for the book, 4 history books, 3 geography books. So it's quite similar to the first one. They were just asking in how many different ways can the books be arranged on the shelf, because there's 7 books, it's just 7 factorial. But then for the next one, they said now you want the history books and the geography books to be grouped together. So that's 2 groups, 4 history books, 3 geography books. And then for the next one, they now said that just the 4 history books need to be grouped together. The geography books can be whatever. So now you need to think that is one group, and then the 3 geography books each form their own group. So 1 and then 3 groups, so there's 4 groups altogether, and then in the history group, because there are 4 books, they can be arranged in 4 factorial ways. Right? And then the last one, number 7, was about the people of the same nationalities living together. I can't remember now what the nationalities were, but there were 4 different nationalities, right? If you look at them. So that is what my first 4 factorial is about. It's the 4 groups of people from the same country. And then I just took, can't remember what it was, I think it was 2 British people at the end. So that's the 2 factorial, and then can't remember really, was it South African? Anyway, it was 3 people at 1, and then 4, and then 4, and then 2. Okay, so this is the groups, 4 factorial, the 4 groups of people, and then within each group, how many people there were. How do you feel about this word, right? It can be a bit confusing when we put everything together. Okay, was there more? Yes. Exercise 13.8, those names, right? The names with the repeated letters. Are there any questions on any of these before we move on? Yeah.
We'll see. I don't know why what I did, but I was like, there's 4 groups. And then
6.
1, 4.
Oh, 4,
And then 1 group. And then I did 4 times.
What are you talking about? Which question, right?
Oh no, sorry for number 4.
4C. Okay, so it was books, right? So they were saying the history books must be put together. So that's one group. And then the 3 geography books, they each form a group. And that's why they are 4 groups. You see, and then within the history group, because they're 4 books, that's the second 4 factorial.
That makes
Okay, slide 13.8. They just came through it with 6 names, and they asked you how many different words or names you can make from those letters. All right, so label, they know repetition, right? For the name label, it's 4 different letters, so it's 4 factorial, so 24. Right? For peach, again 4 letters, so you put the 4 factorial at the top, but now there are 2 E's. Right, so now you need to divide by those 2. Okay, to cancel out all the options where you're just swapping the 2 E's around that are actually the same word. Okay, next one, Nasim, also 2 E's, so you have to divide by 2 factorial, but now there are 6 letters altogether. Right, so at the top you put 6 factorial, and at the bottom 2, or 3 factorial, same thing. Right? All right, Amy. 6 letters again, but now, guys, we have 2 E's and we have 2 N's. All right, so you have to divide by both of those repeats. So that's why there are 2 factorials at the bottom. Okay, and then the next 2 names had loads of repeats. So if we're looking at E, we have 2 N's, right? So that's where the first N factorial, 2 factorial comes from. And then we had 2 T's. So that's the second one. And then we had 2 L's, right? L and L. Okay, and 9 factorial because there are 9 letters altogether. And then the last one again, 9 factorial, but now there are 3 A's. So you must divide by that 3 factorial and 2 ends. Okay, guys, I'm going to do 2 questions from the 2 exercises that I handed out to you because they're just a few loose ends that we need to tie up. I just want to make sure I've done all the types of examples. So you can write down exercise 4, number 2. I have written down the questions, but you don't have to. You obviously have it in front of you. Okay, I just like having it. I'm sorry, on the page as well. So you can just write the heading, guys. Exercise 4, number 2. Yeah. Okay. I'm doing this one with you and then one with one. Okay, have you written exercise 4, number 2? Guys, maybe just write down the winning just so that you know when you're looking at the question in your book. But no. Okay, so now A is a strange question. It's a question that I don't think you'll get in a test or exam because it doesn't really make sense, but they ask it often in this textbook. So they're just saying they consider the letters of the word winning. We can see that we have 2 I's and 3 N's, right? So there are repeated letters there. But now for A, we're saying how many words can be made using these letters if the repeated letters are treated as different letters. And I mean, that almost like doesn't make sense. So what they mean by that, guys, is I'm just going to rewrite winning. So they almost like saying you need to treat the, oh, I must keep my words about me here. You need to treat the 2 I's as if they're different numbers. Okay, so it helps to name them I1 and I2. So they're just kind of saying if you now swap I1 and I2, it is going to be different, which we know is not true, right? But that's just what they're saying in this question. They're saying the repeated letters are actually different things. Okay, which we're not. But anyway, we're just going to go with it. So basically what they're saying for A is there are no repeats. That's what it, yeah, that's the equation of it. So how many letters are there, guys? 7, right? So how many words will we be able to make with those 7 letters if they're all different? 7 factorial. And now again, guys, they're not saying anything about letters being allowed to be repeated, so we assume that you can't repeat. Okay, so 7 factorial, calculator. Oh dear, I don't have it here. Very good. Oh no, it's gonna be a long day. Okay, what's the answer there? 50. 5,040. Oh, 54. Okay, thank you. Sorry. Okay, 5,040. All right, next up. Now, B is now the question that actually makes sense. How many words can be made using these letters if the repeated letters are treated as identical? Which they are, right? Because an I and an I, if you swap them. So this is like the normal type of question, guys. So now we're going to say 7 factorial because there are 7 letters altogether. But now we need to think of the repeats. There are 2 I's, right? So we need to divide by 2 factorial for the I's. And how many N's do I have? 3. So I'm going to have to divide by 3 factorial as well. Okay, what's that answer? 400. Okay, so C. Now guys, this is now where it gets interesting. How many words can be made using these letters if the word starts and ends with the same letter? Now, since I have multiple I's and multiple N's, there are 2 options for this. Okay, So I want you please to write out 7 slots, 1, 2, 3, 4, 5, 6, 7, but then also another 7 slots. So my word is either going to start and end with an I because there are 2 I's, right? Or it's going to start and end with an N. Does that make sense? How many words can be made using these letters if the word starts and ends with the same letter? Because there were 2 letters that had multiples, there would be 2 options. Okay, either the word's going to start and end with I, or it's going to start and end with O. Now guys, so these 2 are fixed, right? So how many options are there for the first slot here? 1. And for this one, also 1, right? It's the same letter. Same thing here. How many options for this end? Also 1. And for that one, also 1. Okay. But how many letters are now in between? 5. Are there repeats within these 5 letters? Yeah, there are 3 ends, okay? So this is going to be 5 factorial divided by 3 factorial. Within the 2 I's. So the 2 I's are fixed. So we can kind of just ignore them. Within the 2 I's, in between them, we still have 5 letters, and 3 of those 5 letters are ends. Okay, so this number that I'm going to get here is the number of words starting and ending with I. Okay, if you want, guys, you can add here the 3 there, those are for the end. Okay, but now we need to think about the other option because there are different types of words that start and end with the same letters. They can start and end with N. The 2 ends are fixed, so we can ignore that. How many letters are in between the 2 ends? Again, 5. Are there any repeats now here? 2 I's, right? So for the second part, we're going to do 5 factorial over 2 factorial. And then add it to it. Yes, exactly. So guys, remember there were 3 ends to start off with, right? But now 2 of them are fixed. So there's only 1 end in these 5. So that end doesn't count as a repeat anymore. Okay, because the repeats actually are now. What's that answer there? 80. Thank you. Okay. How many words can be made using these letters if the word starts with W and ends with G? Okay, so again, I'm going to do my 7 slots. 1, 2, 3, 4, 5, 6, 7. Now that has to be a W and that has to be a G. So those 2 are fixed. Right, so there's only 1 option for the first letter and 1 option for the last letter. In between, we still have 5 letters. Right, do we agree? Are there repeats in between? All of them are actually repeats, okay? 2 I's and 3 N's. So we're going to do 5 factorial divided by 2 factorial times 3 factorial for that one. What's that answer? Okay. Yeah, I just need to fix my spacing here. You guys can read through the next one so long and see if you can do the next one on your own. I have just run out of space, so I just want to read the space myself quickly. Okay, let's look at E. Alright. So now they're saying how many words can be made if the word starts with the letter I. Okay, thanks. Let's focus, guys, please. Alright, so that first one is 6 now. Right? So that is just the one, so we can ignore it. So now we have 6 letters left. So we're going to do 6 factorial. Are there any repeats within those 6? Actually, just one repeat, hey, because now there's one I there, so the other I is somewhere here in the middle. Actually, not a repeat, but we do have 3 ends. The line was a bit long there, but anyway. Okay, what's that answer? 120. Okay, last one, F. How many words can we make using these letters if the word ends with the letter N? So again, 1, 2, 3, 4, 5, 6, 7. Now it needs to end with N. I have 6 letters still. And now, guys, there are actually 2 repeats within those 6 letters, right? Because there are 2 I's and we have 3 ends. One of the ends is now there, but we still have 2. Okay, so that's going to be 2 factorial times 2 factorial. Okay, what's the answer there? 180. Okay, fine, guys. Any questions? I want to quickly do the first question of exercise 5 with you as well, and then you guys are just going to work for the rest of the time. So you can just write exercise 5. Again, I've written the question down. You don't have to. It is on that page. Now, guys, for exercise 5, finally, we actually get into probability. I don't know if you know this. We've been doing the probability section, but we haven't done a single question asking for the probability. Right? We've just done how many words, how many arrangements, how many quotes, right? We haven't actually done probability. So for exercise 5, number 1 is saying, consider the letters of the word night. So there are 6 letters there. Okay, are there any repeats? No. Okay, so it's not 2 letters. If the letters are arranged in any order without repetition, okay, to form different words, what is the probability that the word formed will? So I want you guys just on that page that you have, just highlight the word probability, because we actually haven't done any questions about probability yet. So now they're saying, what's the probability that the word will start with K and end with it? So guys, we know how to work out how many words will start with K and end with T, right? So let's do that. So if we have our 1, 2, 3, 4, 5, 6. The first letter has to be a K, the second letter has to be a T. Sorry, the last letter I mean has to be a T. So how many letters are in between? 4, are there any repeats? No. Okay, so definitely 4 factorial. Okay, that is the number of words that can form starting with a K and ending with a T. But how are we now going to talk about probability? Remember, for probability, you always take the number out if we're thinking of when you're rolling a die. That's the die, right? So I'm asking you, what's the probability that you will end up on an even number? You'll say, okay, there are 3 even numbers. How many numbers in total? 6. All right, so you'll say 3 over 6. So we need to do the same thing here, guys. We're going to put this 4 factorial at the top, but now I need to put that over the total number of words that you can form, excluding this condition, right? Not words starting with a K and ending with a T, just words in total. Okay, so how many words can I form in total using these 6 letters? How did you get that? 6 factorial. right? That is the total number of words that you can form using those 6 letters. Disregarding the starting with K and ending with T. Okay, so now here the probability is going to be 4 factorial over 6 factorial. Okay, I'm just going to add here, I'm just going to write. So you take the number of words starting with K and ending with T over the total number of words. Right, with no conditions put on it. What is that answer if you work it out? 1 over 13, yeah? Oh, 30, sorry. 30? Yeah.
Divided by the.
Yeah. So you can decide what would be easiest for you. You can do it all in one big fraction if you want. But yeah, you wouldn't have to take the repeats into at the top. Okay, start with the letter N. 1, 2, 3, 4, 5, 6. Start with the letter N. So how many words can I make with the rest of those letters? How many letters are left? 5. So this is going to be 5 factorial. Right? That's the number of words that you can make that start with the letter N. So now the probability is going to be those words divided by the total number of words, which is still 6 factorial, guys. It doesn't change from question to question. Right? We're working with the word night all the way through. So the bottom is going to be the same. Right, for all the probability. And someone tell me what that is. 1 over 6. Oh, yes, that makes sense. Thank you. Okay, guys, you are going to do some exercise 4. I would like you to do numbers 3 and 4. Are you circling them, please? 3 and 4. And then from exercise 5, I would like you to do number 2. Number 6. 7. And 9. Not always. Because if you're thinking of, if you are going to do one when yeah, exactly. So the people are different. Grade 12, just an activity. This is for Wednesday, right? I don't see you guys tomorrow. We are also starting a new section on our today. We are starting similarity and geometry. Remember similar triangles? So we're starting it. Yes. Yeah. Guys, am I giving you your taste days?
No.
Okay. Okay.